Good evening, all. Srikanth, sir. Sir, it is audible?
Oh,
Sir,
Yeah.
it is audible?
yeah, it's audible from your
Okay,
side.
sir. So participants are joining now. So shall we wait for 2 more minutes?
Yeah, of course.
Okay, sir. Okay, sir. Okay.
Okay.
Angela, miss?
Okay, sir. Good evening,
Uh,
everyone. Welcome today to our first session. It's an absolute honor to introduce our esteemed resource person for the day, Dr. Srikanth, sir. Dr. Srikanth is an associate professor and the head of Department of Electrical and Electronics Engineering at the College of Engineering Muttathara under Cape, Government of Kerala. With an impressive teaching experience spanning over 19 years, he has not only excelled in academics but also in training and motivating cross-cultural teams. Dr. Srikanth holds a PhD from Anna University and is a brilliant innovator. His remarkable achievement for securing first position at the national level hydrogen hackathon showcases his expertise in advancing technologies. He has also represented India on the global stage by participating in the prestigious World Hydrogen Summit 2024 held in Rotterdam, Netherlands. We are fortunate to have such an accomplished and inspiring personality with us today. Let us warmly welcome Dr. Srikanth, sir, and we look forward to learning from his vast experience and knowledge. Over to you, sir.
Okay. Thank you for your nice introduction. And first of all, I congratulate the team of this Vidya Academy for getting this fund or sanction from AICT for conducting this prestigious online ATAL FDP program. And yes, and I personally I thank all the organizers, those who are working behind this, for giving me this nice opportunity to become a part of this nice event. Thank you. Let me share my slide. Would you be able to see my slide? Hello? 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 Am I audible?
Sir, it is audible.
Are you able to see my slide presentation?
Sir, yes, sir.
Is it okay?
Sir, please put it in the full mode. Okay, sir.
Is it okay now?
Okay, sir.
Okay. Yes, wait for 1 minute.
Okay, sir.
Yeah. Okay. So I think this is the day 2 of this program, and this may be the session 3. I hope so. Am I right?
Yes, sir.
Okay. Yeah. So the title which I'm going to discuss with you is the future of energy. Okay, the challenges and opportunities in green hydrogen sector. And myself, Dr. Srikanth, and the very nice introduction was already given. Yes. So before starting this presentation, a humble request to all the participants, those who are present here, is please consider this session as not just a session of the FDP which give you some knowledge. Okay, of course, each session and each presenter will share some knowledge, and you will get something knowledge in this FDPs. But please consider this FDP is not just a knowledge, and this is a just initiative, mutual initiative of all of us together to give the attention to the global warming and other climate change issues, what we are facing, what we are intensely facing today. So we all know the impact of this climate change and the global warmings and the greenhouse gas emissions, what we are facing today. And this is the collective effort. The collective effort must be there from our all side as engineers to make this world as better for the future generation. So that's our that is a responsibility, all our responsibility. So this is not just attending a session, and consider this more than you're going to take a pledge or initiative to whatever you can do towards this world for all the developments what is happening in this world sustainable. Okay, so this is my humble request, and we can start with a quote. The world has enough for everyone's need, but not enough for everyone's greed. So we should always remember this, right? And excuse me, anyone from the participants, do you know the quote is from whom? Excuse me. The very important quote, with the very important quote in this scenario. Excuse me, anyone? Okay, right.
For everyone's need, but not enough for everyone's greed. Whose quote is this?
Yeah, okay. So this is nothing but from the great man, Mahatma Gandhi. Yes, so this is what I requested you in the very beginning. So we know that all the resources what we are using nowadays, the energy for the great developments is getting depleted day by day. So we are the collective response. These are all the collective response of all of us to keep some or to conserve the energy for our future generations. Then only we say that the world becomes sustainable. So this is the very first thing we have to remain keeping in our mind before listening the rest of the slides. Okay. Yes. Thank you. Yes, we can start with the Sustainable Development Goals. You may all aware about these SDG goals. So there are 17 Sustainable Development Goals are there. This goal has been framed by the Department of Economic and Social Affairs, United States. And these all SDGs are framed in the year 2050. Okay, and 17 SDGs are there framed, but here we are going to take some of that SDGs out of that 17, which is closely related to what we are going to discuss today, or it is closely related to energy, sustainable energy. Okay, And the first one, we are going to take the seventh one. Affordable and clean energy. Ensure access to affordable, reliable, sustainable, and modern energy for all. And this SDG is very closely related to your FDP title. Okay. And SDG 9, industry, innovation, and infrastructure. Promote inclusive and sustainable industrialization and foster innovation. And number 11, SDG 11, sustainable cities and communities. So that means make cities and human settlements inclusive, safe, resilient, and sustainable. Okay, and this SDG can also very strongly map to your FDP title. And the 13th one is climate action. Of course, we're all aware of that. Take urgent action to combat climate change and its impacts, because this SDG is the very critical one. And the intensity of this climate change, or the impact of the climate change, what is making nowadays is very, very intensive. And we are all aware of that. And we all can feel what is the impact of this climate change. So sudden action or the urgent action is needed in this category. Okay, so the very important SDG number 13. And so we are taking these 4 SDGs, what we have discussed up to now, is the thing which can consider now. And other SDGs also important. And these 4 SDGs are taking in this category and in this scenario, in today's scenario. Yes, the future of energy, as already we said that we need to conserve the energy for our future generation, and in turn we are in a position to make the future of energy as safe one. So on this scenario, we need to remember another quote. Okay, so that quote is from Jules Verne. So this quote is the very nice quote. And so how he had given this quote many years before. I believe that water will one day be employed as fuel, that hydrogen and oxygen, which constitute it, used singly or together, will furnish an inexhaustible source of heat and light of an intensity of which coal is not capable. Okay, and very years before he quoted that, and now it is going to be the truth. So that means nothing but that hydrogen. Hydrogen is going to rule the world tomorrow, rule the energy world tomorrow. Okay. Yes. So this is what the hydrogen is introducing into this energy field. And the reason behind this has already been discussed. The world is facing a pressing need to transition towards a sustainable energy future, because we all know that as the engineers, the development is very, very, very fast, and intensive development is there. And the question is whether all the developments happening here is sustainable or not. That is the question. And of course, it is not sustainable. It is not sustainable, and there is a pressing need to transition. A very, very crucial transition is needed today. In this scenario, a very crucial transition is needed. What is the sustainable energy future? As we move away from fossil fuels, renewable energy sources are gaining momentum, and there is no need to discuss the impact of the fossil fuels, what it is making into the atmosphere, and it is no necessary to discuss that all things. And that's the reason why renewable energy is taking into the part. And among these, and already the renewable sources are there, and we are all aware of that. And but among these, green hydrogen emerges as a promising one. Okay, we need a better solution for this sustainable future, and this hydrogen is going to be the promising solution, which offers a clean and versatile energy carrier. Okay, this is the energy carrier. So that's a very emphasizing thing. A clean and versatile energy carrier with the potential to revolutionize various sectors. Okay, its utilization is multi. Yes. Hydrogen. Yes. Could you please anyone say what is this 1.008 mentioned in this slide? Excuse me. Could you please anyone mention what is this 1.008? Yes, I'm expecting a what two-way communication, or otherwise the session will get bored, because already the session is the online mode, and if there is no reciprocation from your side, the things will get highly bored. Excuse me, what is this 1.008? Anyone?
Atomic mass.
Yeah, exactly. Thank you. So this is and we are all aware. In the school days, we in chemistry subjects we have studied this periodic table and details of these all things. And this is the mass, atomic mass of this hydrogen. And as we all know that this is the gaseous element in biomolecular form H2, and it is the lightest element. So this is already the very basic knowledge you might have. Lightest element in the periodic table, which has energy per unit mass is 110, because this is the very highlight, because this hydrogen is energy intensive. So the energy per unit mass is 120 mg per kg. So this is what makes the hydrogen as a special one. Okay, and the most abundant element in the universe. It's the very abundant element in the universe and have utility in many applications. And it has very high calorific value based on mass and low volumetric energy density and excellent reducing agent. So these are some of the highlighted things of the specifications which we can discuss just for a fun. And this, have you heard of that? Very recently, from this year onwards, there is a celebration, the World Hydrogen Day. From this year 2024. The world is going to celebrate the World Hydrogen Day, and that World Hydrogen Day is celebrated just a couple of months back. That is October 8th. October 8th is the World Hydrogen Day, and why? The funny thing behind that is it is based on that the atomic mass of this hydrogen, that 1.008. So that means 1008, October 8th. So that is the reason why the world is decided to celebrate the World Hydrogen Day in October 8th. Okay, yes, thanks. And some more details. It's a super versatile energy carrier with exceptional energy density. The energy density is very, very high. Okay, and today around 70 million metric tons of hydrogen are produced globally. Okay, already all countries has its ambition to make these developments sustainable, and they are in the path of means replacing the fossil fuels by the renewables, and especially by hydrogen, and used across an array of sectors, that is fertilizer, refining, petrochemical, and glass manufacturing. In industries, lot much of requirement is there, because we need to replace all the fossil fuels which are now being used in the industry. And in the future, hydrogen will have a huge role to play in decarbonizing the global economy. As I already said, it has a huge role, because we need to have some solution for this global warming, and definitely this hydrogen is going to play a big role on it. Okay. But as of all these things, lot much of challenges there. Lot much of challenges is there for using this hydrogen as the energy, and we can discuss what are they. And you can take some look on this, and these are some of the properties of the hydrogen. As already we discussed, the atomic weight is there, and the molecular weight, melting point, its boiling point, its density, and all the details are there. Okay, you can have a look on that. Yes, and we can have a look on some milestones. Okay, hydrogen, as already is that it's not the new one. It's already been in there. The area of scientific field. So it was emerged. It was not a new one, and is already emerged in 1838. the hydrogen fuel cell was first developed for the generation of electricity. See, in 1838 itself, hydrogen fuel cell was developed. See the gap. And there is a question that there is a gap why this technology is not yet matured. And 1838 is the year which the first hydrogen fuel was developed. In 1960, okay, the hydrogen fuel cells for generating electricity with the portable water as byproduct in the Apollo and Gemini space missions of NASA were supplied by the General Electric. So 1960, from the 1960 onwards, commercially it has been used for the various purpose. And in 2004, the underwater hydrogen fuel cell vehicle was launched under German cooperation project named as Deep Sea. Okay, 2004. This was a great revolution in that period by developing this underwater hydrogen fuel cell. Okay, by German collaboration. And in 2013, the first 2 megawatt power to gas project, okay, was commissioned in Germany. And in 2018, the first hydrogen powered train, in 2018, the first hydrogen powered train was operational in Germany. And we can say that, we can proudly say, anyhow, coming in that feature slides, we can proudly say that the India is going to run India's first hydrogen train in this month. It is already, the train has already built and it is ready for the trial run in this month. In 2019, Alkite Technologies designed Sky Simple Air Mobility System, the world's first hydrogen-powered air mobility system. Okay, in air mobility system, already I think it is also from German side, they had developed the first hydrogen flight. So these are all, this is not the new thing. Already the various part of the country has started their own innovations in the hydrogen field. Okay, and a lot much of applications and utilizations are already there, and a lot much of research is also happening in different parts of the country. And we can see some insights of this hydrogen. So we have different forms of hydrogen based upon the production technology used for the hydrogen generation. So we can have some rainbow of these colors of the hydrogen. So black hydrogen, brown, purple. So these are all the colors of the hydrogen we can produce. Okay. Example, the color black hydrogen is nothing but the method used for the development or the generation of the hydrogen is coal gasification. Okay. Brown is brown coal gasification. Purple is coal or petcoke gasification with CCS, so that is carbon capture system, carbon capture and storage. And gray is natural gas reforming. Gray is the very common one of these all hydrogen. Gray hydrogen is the very common one, and that hydrogen is generated by natural gas reforming, the very familiar method used for the nowadays used for the method for the generation of the hydrogen. So there is gray hydrogen, and other some hydrogen also there. Okay, you can make a look on that. So these are all the different colors. Lot much of colors of hydrogen are there. Yes, of course, I need to say that the hydrogen is invisible to our eyes, and that is the reason why the hydrogen is one of the dangerous thing we need to, when we are playing with this hydrogen research and all these things, it's heavily dangerous. It is invisible to us, and the heat or that spark produced from the hydrogen is also invisible, and if you are not taking care of that, not much of danger is there in connection with this hydrogen. Okay. And please don't misunderstand that these hydrogens are in these colors, and the color is only based on the production technology used for this hydrogen. Okay. Yeah. This is the another version what is already mentioned, gray hydrogen. The process for the production of the gray hydrogen is steam reforming. Okay. So lot much of methods are there. Lot much of methods are there for producing hydrogen, and this gray hydrogen, as I already mentioned, this is the very popularly used hydrogen for the various purpose in industries. Okay, and the process, the method is used for this production of this grey hydrogen is steam reforming, and the source is natural gas, blue hydrogen. Okay, and this hydrogen is produced through the process steam reforming with the carbon capture. Steam reforming with the carbon capture, and here also the source is natural gas. Yes, so this is the master of in today's scenario, green hydrogen. So the process is electrolysis and the source is renewable energies. And this is black hydrogen, the process is gasification and the source is coal. The pink hydrogen, the process is electrolysis and the source is nuclear energy. Turquoise hydrogen, the process is pyrolysis, okay, and the source is natural gas. Pyrolysis is, I think, this is the method used for generating or producing hydrogen from solid municipal waste. So we can generate hydrogen from solid municipal waste by using the process pyrolysis, and we can say that the type of hydrogen is turquoise hydrogen. Okay, yes, so as we discussed, so different types of hydrogens are there. So this is the representation of that, the same thing what we have already discussed, the various methods, and of this what we can see in the left side is nothing but the by using the renewable sources, the producing hydrogen is nothing but the green hydrogen. Okay. So the technology is entirely based on fossil fuels. Okay, so what at present most of the production of the hydrogen is based on the fossil fuels, and around 71%, as already I mentioned, 71% of the hydrogen is gray hydrogen. So that is steam methane reformation or SMR, while most of the rest is brown hydrogen. And the major category, the global category of the hydrogen which is producing nowadays is nothing but gray hydrogen. So this process have been around for decades. It's already there. As we discussed, it's already there. So the challenge is dealing with carbon and high emission that results. So because hydrogen is there, but the gray hydrogen is not the good one, because again, if you're producing or generating hydrogen using the fossil fuels, again we are creating a lot much of problems to the atmosphere, and again the greenhouse gas emission is not going to control. So that because our aim is to get controlled on the greenhouse gas emissions, so definitely we must go for green hydrogen. So the future for the current technology is all about blue hydrogen, where the production process is paired with carbon capture and storage. That is also admissible, but CCS have not much of challenges. Okay, if we are using carbon capture and storage technology, we can produce the blue hydrogen, but not much of challenges are there. We cannot go for the commercial type of a CCS. Not much of things are there behind that. Okay, so the demand is high for green hydrogen. So why we are discussing all this thing is we need to know the situation why we are going for the green hydrogen. So this is all the reasons the demand for the green hydrogen is very, very, very high nowadays and in the future. Yes. So some of the technologies is there. Okay, and already so that I told you that reforming technologies. These all technologies are mature technologies. Okay, from 2 decades before, these all technologies are available, and reforming and the raw material is water and natural gas, and form of energy is heat, and electrolysis, the raw material is water, and form of energy is electricity. Okay, and future technology is coal gasification, and that can be used for the CCS and CSS. Then radiolysis. So these are all the future technologies. Yes, the supply versus demand. So that is the major thing we need to discuss. Already the renewable energy is not much of renewable energy is matured in renewable technology is there, as like solar, wind, hydroelectric, that all technology is already matured, and we are using these all technology for generating or using energies. Okay, but the demand is high for the hydrogen now, because the demand is going as fuel cell engines and fuel cell internal combustion engine, commercial, residential building, and industry. So industry is the major category which is using most of the energy nowadays, because we cannot avoid the development. Technological development is mandatory. We need to have this technological development, and major portion of these developments are based on the industrial revolutions. Not much of industrial revolutions are there already we came across, and we are now, the world is gearing up for the next industrial revolution. Okay, the world is gearing up for the next industrial revolution. So that means lot much of energy is required for that what that revolution, industrial revolution. So we need to, the critical thing is how we can meet the energy for that critical revolutions or the industrial developments. So the demand is very, very high for this green hydrogen. The green hydrogen process is zero carbon and gives very pure hydrogen, whereas gray or brown hydrogen contains impurities. Okay, and in the very starting itself, I told you that the energy, hydrogen, the GH2, the green energy is the clean energy solution. When we discussed the very first slide about the SDG, Sustainable Development Goals, we need to provide the clean and sustainable energy. Okay, so we need the very clean energy, so which will not make any impact to the atmosphere, so that we can reduce the greenhouse gas emissions. So why this green hydrogen is becoming the clean energy? The reason is the zero emission. Okay, so the very first reason is the zero emission, it's zero carbon, very pure hydrogen is the specialty of this green hydrogen. And the idea is that green hydrogen piggybacks on the rapid rollout of renewables in the coming decades. So that is already we discussed. When there is surplus renewables, price will drop, becoming cost effective for green hydrogen. As of course, if you are thinking whether this green hydrogen is economically feasible, means we cannot say the answer now, because the lot much of maturity is needed for the technology behind this green hydrogen production. We all know that the solar, how the solar become mature. So nowadays it's become cheaper, but think 10 to 15 years or 20 years back, the technology was there. The solar technology was there, but that was not matured, and the cost is the cost was very high for this solar technology. And due to lot much of research and development activities and lot much of policy decisions by the governments and the countries, now this solar technology become very feasible and is very reachable to everyone, and this economic feasibility is there. And so we are almost all the people are going is nowadays using this solar technology. So this way, this green hydrogen technology will also become economically feasible in future days. So lot much of, we need to cross lot much of hurdles for that. Okay, yes.
So
yes, the increasing demand for clean hydrogen. Okay.
Sir, your mic is muted.
Is it audible now?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Yeah. Okay. Okay. Sorry. wait. Yeah. So unlike conventional hydrogen production methods, and as already said, the gray hydrogen is the carbon intensive one. So the green hydrogen generated through electrolysis of water using electricity from renewable sources, ensuring a carbon neutral outcome. So that is the emphasizing point. So the carbon neutral outcome of this green hydrogen production using the renewable sources is going to make this energy as the clean energy carrier one. Okay. And of course, this green hydrogen has diverse applications. It has diverse application across industries, transportation, then industrial process, so that it make it as a versatile energy solution. Yeah. Why? Why it is needed? And we have discussed what is hydrogen and what type of production technologies are there, and what is the specialties of the, or what are the features of this green hydrogen, these all things, and why it is necessary for nowadays developments. And the reason is many industries and transportation sectors rely on fossil fuels. You all know that. That is what I already mentioned. The most of the energy requirement is in the transportation sectors and industries, and for that we are using the fossil fuels, and that are difficult or impractical to replace with the electricity directly. Okay, it is not at all possible to replace that all fossil fuel sectors which are using fossil fuels with electricity directly. Okay, and the next one is renewable energy storage. So the sources like solar, wind power are variable, and we already say that we are giving not much of importance for using the renewable various renewable energy sources for this development purpose. And even though these are all there, the each one has its own drawbacks or the limitations. Like solar, the full-time availability is not there, and wind, the availability of the wind in different geographical situations. So these are all the limitations which makes these all renewable sources as a unique one. Okay, so that means we can't produce the electricity consistently by using this renewable energy. So the green hydrogen can be produced using excess renewable energy and stored for later use. So that is the advantage. We can store this energy and for the later use, helping to balance the grid and ensure a reliable energy supply. And energy security and independence. We know that the major expenditure for our government national wide is the importing of this the fossil fuels, crude oil. Okay, we are importing lot much of crude oil. The very big portion of the category of the budget is for this importing this whole crude oil for the for using the as energy for various industries and the mobilization sector. And we need to have an independence from that, so that it can be happened by the green hydrogen that can be localized, reducing reliance on the fossil fuels imported from other countries. This can improve energy security. Once we are able to produce the green hydrogen, localized green hydrogen production is there, so we can become or we can avoid the relying on fossil fuels can be avoided by producing the green hydrogen in the as localized one. Okay, so this will improve the energy security and independence for nations seeking to diversify the energy sources. And some, of course, environmental benefits are there. Unlike traditional methods that produce what is known as gray hydrogen, green hydrogen production using the renewable energy create no greenhouse gas emission. And as already we discussed, this is the significant one which reduces the environmental impact. Yes. And as already we said, the climate change is the very big issue what we are facing, and how we can relate the climate change and fossil fuels by have a look on this graph. Okay, so globally the CO2 emissions were 417 ppm parts per million, amounting to 36.8 billion ton in the year 2022. Sorry, that is 2022. In the beginning of Industrial Revolution in Europe in 1750, the CO2 emissions were 275. It is clear from that chart. And we are getting delayed in taking the corrective actions. So see, the actions are already taken, and this is delayed. And quick action is necessary to make a big impact on this CO2 emissions. Then only we will be able to reduce this greenhouse gas emissions, and which that we can avoid the damage of our Earth, which happens to be the only known planet in suppose. Because as already I said, we need to keep this planet as safe as possible for our future generations, and then only we will be what these all developments what we are making today will get used by our future generations. Yes. Okay. So as a decarbonization tool, if the green hydrogen could be used for the reducing the greenhouse gas emission or emission-free energy, then we can call this green hydrogen as a decarbonization tool. How? You can have a look on this chart. So green hydrogen, how the green hydrogen has an diversified applications in or utilization in various fields. You can see there refineries, fertilizers, steel, methanol, and in mobility, trucks, buses, shipping, aviation, and as a energy carrier. It's very important. And the very first itself, I told you that the green hydrogen is a clean energy carrier. It is not an energy. We can carry this energy. Okay, green ammonia and blending with natural gas. So that way we can carry this energy. So this is the what specialty of this energy, and we can store. Of course, we can store this energy, hydrogen, in various forms. In various forms, we can store in gas, and liquid hydrogen. So various forms we can. Of course, even we can store it as in a powder form. Also, it's possible to store the what this energy hydrogen. Okay. So this is nothing but the chart which shows the present Indian scenario of this greenhouse gas emission and its contribution. And percentage-wise, this contribution is, you can see that the 44%, the major percent goes for the electricity production. Okay, the 44% is go for the electricity production, and the 18% for the industries and construction, and other categories you can see the transport, agriculture, and waste, and like this. But the major portion goes for the electricity production and industry purpose. So this category, the 44% and 18% is creating lot much or is responsible for this greenhouse gas emission nowadays. Okay. Yes, the necessity of green hydrogen in Indian scenario. In Indian scenario, what is the necessity of this green hydrogen? The power generation, especially through fossil fuels. We all know that the power, how in various ways we can generate the power. The power generation, especially through fossil fuels, mainly by coal and thermal technologies are there. And anyhow, these all depends on or rely on the fossil fuels, and is accompanied by numerous environmental repercussions. So that is a great impact on the greenhouse gas emission. That is simply the increased global warming experienced during past half century has compelled the world to establish reason and means to curb within the safe limits. Okay, and we know how much of energy and potentially is there for generating this electricity nowadays. So globally, most of the hydrogen is produced by SMR, as already we discussed. However, in the hydrogen economy, the focus and the priority around the world is rapidly shifting towards green hydrogen, and all other methods are there. The world is rapidly shifting towards the green hydrogen generation, which is majorly produced by electrolysis process, which is produced by electrolysis of water using renewable energy. Yes. Now we can move the green hydrogen production by electrolysis. So this is the major part here. How we can generate green hydrogen from electrolysis. Globally, most of the hydrogen is. So this is the way. Yes. Sorry. if you, sorry, this is the, you can have one look on this block diagram. So this is the way how we can produce green hydrogen using water. Okay. So as already mentioned, the technology here is nothing but electrolysis, and we are using the electrolyzer for that splitting of water. And the power requirement of the electrolysis is met from the renewable sources. And we are generating hydrogen from the electrolysis process, and we are storing the hydrogen. And then that stored hydrogen can be used for diversified applications. And this is why this hydrogen become green is we are powering the electrolyzer through renewable sources. So this is the major point here. So that we are calling this hydrogen as a green hydrogen. Okay. So most of nowadays, most of the people are thinking, what is this green hydrogen? So this is the thing behind that, why we are calling it as a green hydrogen. This is some of the another version of that, what already we discussed. Yes. Electrolysis. So the process here is electrolysis. The four main type of electrolysis mainly different electrolyte and operating temperatures, which provide the basis for the selection of materials. Alkaline electrolyzer uses liquid electrolyte, and the other three electrolyzers, namely PEM, AEM, and SOE. So these are the major category of the electrolysis available in the market now. PEM electrolyzer, polymer electrolyte membrane. So that is a PEM electrolyzer. Then AEM, anion exchange membrane electrolyzer, is the AEM electrolyzer, and SOE is the solid oxide electrolyzer, that is a SOE electrolyzer. So these are the major categories of the electrolyzers available in the market today. And these are some of the specifications and the details of that each PEM, AEM, solid oxide, and alkaline electrolyzers. Okay, so you can have a look on that. So mainly the membranes used in these electrolyzers varies for the various type of electrolyzers. You can see on that specifications. Yes. So the production system, we need to have a production system for generating green hydrogen. So we can produce this hydrogen using different systems. Okay. So some of the systems are mentioned here. So first one is the cell level production system. The very basic unit comprising of anode, cathode, electrolyte. It's a cell level, the very basic level production system, cell level system. The next one is stack level system. So that is, it is nothing but the collection of cells together is nothing but the stack level production system. And the next one is system level system. It includes balance of plant of an electrolyzer, which are subsystems necessary for the proper functioning of main production. Because if you're going for a big scale of production, hydrogen production, the system level production will be most suitable, and the stack level, cell level is only used for the very light production of hydrogen. And when you're going for the commercialized production of green hydrogen, the system level is used. Okay, so depending upon hourly rate of hydrogen production, manufacturers limitations and DC power supply limitations, instead of single large-scale electrolyzer stack and combination of small interconnector. I told you that if you're going for a system level, we need interconnection of different stacks to make a big level of hydrogen production system. And to receive the electric power supply and separate pipe connection for collection of hydrogen and oxygen gases are preferable. When you're going for the higher or the high scale level of hydrogen production, and it is complex and lot much of infrastructure is necessary for that system level production. Okay. Some things we need to remember is depend for a hydrogen based economy to develop. So we need to create a hydrogen based economy. The purity of the hydrogen has to be ensured, and the production must be cost effective, and expanded infrastructure are some of the prime prerequisite. See, listen here, we need some prerequisite for this production of hydrogen. Okay. So that the main one is we need to create the economy, hydrogen based economy has to be developed, and so that we can make this as the cost effective one. And the green hydrogen and this electrolyzer technology are at the center in the production of green hydrogen. Okay. So presently, the alkaline and PEM electrolyzers, as we discussed earlier, the type of electrolyzers are two commercially available technologies. We discussed different types of other two electrolyzers also there, but alkaline and PEM electrolyzers are the commercially available technology for production of green hydrogen. Okay, so these two electrolyzers are very majorly used for, and of this, PEM electrolyzer is mostly suitable, and some advantages and disadvantages are there for both one. Okay, and advanced electrolyzer technology that SOE is also there. Yes, challenges. So not much, as already mentioned in the starting, not much of challenges are there. One of the main challenges is the economic challenge. Green hydrogen has to compete with SMR hydrogen with the cost between 1 to 2 US dollar per kg. Okay, and this is the present situation, and these are the costs that green hydrogen can't even get close to currently. So this is the reason, because I already mentioned we need to, once the technology is not get matured, of course it will not get economically feasible as the solar technology. Now the solar technologies get economic feasible, and it is reachable or viable to all public or the normal human beings. And presently this type of hydrogens and the green hydrogen is costly, and the reason behind is we need to not much of maturity of the technology is needed. Okay, and the economic only work on unrealistic assumptions today, high load factors, more than 50%, and low electricity prices. The lot much of factors are there why this green hydrogen is high cost one. Not much of things are there. Okay, and but right now a green hydrogen plant paired with a renewable source could expect load factors near 20%. Typically, power purchase agreement prices for renewables, because if you are powering the electrolyzer from grid and it is not viable, and if you need to power the electrolyzer from the renewable sources, lot much of renewable sources is needed. For example, if you are powering an electrolyzer from solar power, and lot much of solar panels are needed for powering this electrolyzer, and that type of lot much of challenges are there still to address. Yes, so these are the various roles of this hydrogen: fuel for transport and power, and as heat. So this is the various forms of hydrogen. If you are considering it as a fuel, that can be used for transport and power. If you are considering as heat, it can be used for industry and buildings. And if you are considering hydrogen as a feedstock, that can be used as chemicals and products. Okay. Green hydrogen consumption. So the global trend, the present global trend of this hydrogen consumption, it is not green. Okay, keep in mind this is not green. Hydrogen consumption. So that may be the hydrogen may be the gray one. So petroleum refining has the 25%. Then ammonia production, the great demand is in the sector of ammonia production. We need hydrogen. Not much of amount of quantity of hydrogen is needed for this ammonia production. So the 55% demand is go for the ammonia production, and 10% methanol, and other mobility is 10%. And in industries, as already we discussed, industries, steel production, not much of hydrogen is needed there, and cement production. I'm not going to discuss in detail because of the time limitation. Okay, and then electronics, of course, metalworking, medical field is also there. Lot much of demand of their hydrogen. Hydrogen therapy is there in the medical field. Yes, the main thing is we are going to discuss is the power generation. Okay. So the conventional, we all are aware of that, the conventional method of this power generation, and we can see how this hydrogen is going to make the change in this field. Okay. So the increased global warming experience, as we discussed earlier, we are going to replace this electricity generation, the conventional method of electricity generation, by this hydrogen. How is possible? We can discuss. And in mobility sector, how this hydrogen can play a vital role in mobility sector. We can use fuel cell technology in mobility sector, where the hydrogen is given as the input to the fuel cell, and the fuel cell gives the electricity, and by using the battery we can run the vehicles. And here also the fuel cells, as we discussed, fuel cell is another type of electrolyzer. It is also in the process of the technology is very similar to the electrolyzer. And the proton exchange membrane fuel cell operates at low PEM. As we discussed earlier, the PEM fuel cells are the very familiar fuel cell which is used in the mobility sector for generating electricity from hydrogen using fuel cell. Yes, okay. And yes, already the fuel cell vehicles were already been invented, and Hyundai in Korea was the first to introduce the hydrogen fuel cell powered car model in 2013, followed by Mirai by Toyota. The Mirai is the model and released in Japan in 2015. And other notable manufacturers model include Honda City, Hyundai Nexo, and BMW is also released their own hydrogen vehicles. Okay, and these are some of the benefits of the hydrogen fuel cells. Yes, so this is the interesting factor you can see here. Okay, so we can assume or we can have a case here, a light duty fuel cell electric vehicle, as the nowadays electric vehicles can drive approximately 95 kilometer fuel cell electric vehicle with 95 kilometer with 1 kg hydrogen, whereas conventional vehicles, we are going to compare the conventional vehicles and the hydrogen vehicles. Okay, the conventional vehicles drive for 40 to 50 kilometer from 1 gallon of petrol. You can compare the efficiency or the distance covered by these two fuels. Okay, so 95 kilometer with 1 kg of hydrogen, whereas 50 kilometer from 1 gallon. So that is approximately 3 kg of petrol. Yes, and the US Department of Energy is executing a research project which aims to increase the fuel efficiency so that a light duty vehicle travels 160. So that is already the research and developments are going on, and this hydrogen or the fuel cell vehicles are not yet commercialized, and still not much of research and developments are going on there, and the increasing the mileage or the efficiency of these fuel cell vehicles is getting increased, so that the different societies and the different organizations are doing research to increase the efficiency of using hydrogen. So this is the model of the fuel cell electric vehicle. Okay, a hydrogen tank is there. We will fuel the hydrogen into the tank. We will give the hydrogen as the input to the fuel cell, and the fuel cell generate the electricity, and then it becomes the, as usual, our electric cars. Once the electricity is produced, and the vehicle can be run using this electricity. Okay. Yeah, so this is the Honda FCX Clarity of vehicle that already released, and the other picture shows the India's first green hydrogen based fuel cell. The Toyota Mirai is the first model launched in India. I think just 3 years back. So that was the Mirai, Honda Toyota Mirai model, and it was already used in some of the cities in India. Yes. So here is another interesting factor. So how, when we are using the fuel cell electric vehicle, how it is, we can think what is the efficiency, energy efficiency of using this fuel cell vehicle is very clearly mentioned here. You can see that the input to the fuel cell vehicle is, if we are giving an electric energy, if you are giving an electric energy of 100 joules for an electrolyzer, okay, because fuel cell vehicle has the fuel, we are going to fill hydrogen instead of what electricity. Okay, instead of electricity for the EV vehicles, or instead of filling petrol to the conventional vehicles, we are filling hydrogen. Okay, and we are going to make a case study, the energy efficiency of this fuel cell vehicle. Okay, if 100 joules of energy is electrical energy from power plant, it has 100 joules. If you are giving to the electrolyzer, and that is given to it produces hydrogen, and when it is producing hydrogen, the losses are mentioned there. Okay, power grid loss is 6%, electrolysis, that is the loss of energy. It is mentioned in the red colors. It is the loss of energy in each process. In the production stage, when the green hydrogen is developed, this much of loss is happening there. 6% loss is in the power grid, 30%, greater than 30% loss is there in electrolysis, and it is get compressed. Okay, before giving to the vehicle, it need to be compressed. We need to maintain the pressures in that standardized manner. Then only we will be able to get or take feed to that fuel cell. So during compressor, 10%, again 10%, more than 10% energy loss is there, and it goes to motor and controller. Again, a 10% loss is there, and fuel cell loss is there, that is greater than 40% loss. So totally, so finally that 100 joules become 32 joules. See, you can imagine that how much energy is spent when we are using hydrogen as a fuel to run a vehicle. So this is the present scenario. Okay, and the formula is given how the efficiency can be calculated. Fuel cell vehicle. What is the fuel cell efficiency of the fuel? We know that what is the efficiency of our nowadays running the EV vehicles, and we can calculate the efficiency of that EV vehicles. As here, we can calculate the efficiency of the fuel cell vehicle, and the comparatively the efficiency is very poor in FCEV, fuel cell electrical vehicle. The efficiency is very poor, and as already mentioned, we need to mature this technology. Lot much of challenge is there. Lot much of research has to be done so that we can reduce the or increase the reduces the losses in various stages. In turn, we can increase the efficiency of this hydrogen or the fuel cell electric vehicle. Yeah, we can compare the battery EV versus fuel cell vehicle. Okay, so please make a look on to this. Nowadays, we are charging the batteries in the EV vehicles from the grid, and it is not sure that, and we can't say this is the green one. Okay, so because the electricity is produced using the fossil fuels, and already the emission is there, and we can't say that the electric vehicles what we are running today is the green one. Okay, comparatively, it is good as the fuel of fossil fuels in the petrol vehicles. Comparatively, it is good, but it is not green. The emission is still there in the electricity production side. So if we are comparing the efficiency of this electric vehicle and the fuel cell vehicle, you can see that electricity from renewable energies. Considering that we are using the electricity from renewable energy, okay, not from grid. If we are considering the electricity from renewable energy both for the EV, battery EV and fuel cell, you can see that 100% is the input side, and in the conventional electric vehicles, transformation, the AC/DC side, distribution get 90%. It is that means nothing but the efficiency of that section is 90%, and storage plus charger is 95%, and in the vehicle side, battery and converters. Okay, so battery has the different types of batteries that we are using. 95 and 90 are the efficiency of that side, and the converters has 98% efficiency, motors has 92% efficiency, and the transmission has 98% efficiency. So altogether, a battery electric vehicle has 65% of efficiency. Okay, so when you're coming to that fuel cell electric vehicle, okay, so this is the case for electric vehicle. When you're coming for the fuel cell electric vehicle, if the hydrogen is produced centralized production of hydrogen is there, we can see what are the efficiencies of each stages. Water electrolysis there is a process, that is the main process for hydrogen production, and the efficiency of the electrolysis can be taken as 70%. Okay, and distribution, we need to distribute this hydrogen to different places or the different stages. The distribution stage has only the 0.85%. The efficiency is only 0.85%, and the compression of the hydrogen has 85% efficiency. And when come to the vehicle, okay, as compared to the battery electric vehicle. When we are coming to this fuel cell electric vehicle, as like battery here, fuel cell. Instead of battery, we are using the fuel cell. We are using the PEM fuel cell. The efficiency of that fuel cell is 50%. Okay, the battery in the EV vehicle is 95%, and the PEM fuel cell in the for fuel cell electric vehicle is 50%. And the converters, as like in the previous one, there will not be major change in that efficiency change in that section. Same as 98, 92, 98% in the converter side, and totally and altogether it becomes the efficiency reduced to 22%. Okay, 22% may be the efficiency of the fuel cell electric vehicle if the hydrogen is produced centralized. Okay, and if the hydrogen is produced on site, the total efficiency will rise 1%, 22 to 23%. Okay, so this is the insight or the good comparison that we can make. Still, we can say that lot much of what compromising is needed in the fuel cell electric vehicle. If you are comparing the efficiency, at present it is not feasible. At present, this is not feasible, but already told, lot much of maturity and lot much of commercialization and lot much of localization has to be emerged. Then only we can make. Then only we will be able to increase the efficiency of fuel cell electric vehicle. Okay. Yes, hydrogen powered trains. Okay, as in the mobility sector, we have discussed about the vehicles or the road-based which are using this hydrogen technology or the fuel cell technology, and there are also already mature technologies there for the rail transport. The hydrogen is can be used as fuel in trains to run the trains, and then it become hydrogen powered trains. Lot much of research, and already the German has released their hydrogen train just 5 years back. And as already mentioned in the first slide, India has India released going to run the trial, going to run trial in hydrogen train in the coming. I think it is going to be run in this month itself. Okay, then a hydrogen powered flight is also there. The technology is also there and is getting matured. And the world's first pilot flight electrically aircraft powered by liquid hydrogen. It is also developed by German. Yes. So this energy, what we discussed, the green hydrogen, the great energy carrier, and it has the multiple applications. We can see a very simple animation, so that you can see how this production of this hydrogen and utilization of the hydrogen. Please watch the animation. So one side shows the different types of hydrogen production, and another side shows the transportation of this hydrogen and in various forms, how it is transferred, ammonia and nitrogen, then oxygen, and how that can be used for the various utilization purpose. Okay, so so you can see that multiple applications are there and multiple utilizations are there for this green hydrogen. Okay. Yeah. Now we are going to discuss the opportunities, emerging opportunities for green hydrogen in India. Okay, hydrogen is becoming increasingly critical as a fuel for India's core industrial sectors. The country produces and consumes an estimated approximately 5.6 million tons per annum of grey hydrogen. Okay, at present, most of the hydrogen is green hydrogen, and annually amounting to nearly 6% of the global consumption. Comparatively, the India having the 6% of global consumption in the hydrogen. So to actualize India's aspirations of building low carbon and self-reliant economy, the government of India has declared the green hydrogen a sunrise sector, MNRE 2023, and enacted supportive policies to enable industrial shift to achieve this vision by 2030. As countries around the world also look to transition to green hydrogen, Indian policymakers see an opportunity for the country to attract foreign investment, develop robust electrolyzer manufacturing capabilities, and lead innovation in this sector. See, as already I told, to encourage the production of this green hydrogen or to encourage the utilization of the green hydrogen, lot much of initiatives must be there from the government side. Then only we will be make this technology as a reliable one, and the technology which is acceptable to all categories in the nation. So lot much of activities and a lot much of initiatives are taken by the central government and the state government at present. Not much of initiatives are there, and the main initiative from the government side, the central government side, is the National Green Hydrogen Mission. So the government is launched the National Green Hydrogen Mission in 2023. Under this mission, lot much of initiatives are there taken from the lot much of incentives, policies are there. As a couple of decades before, India has lot much of initiatives are there on the side of renewable like solar and wind. So because of that initiatives, only nowadays the solar and wind energies become feasible to all. So likewise, we are giving lot much of incentives and supported policies are taken by the government to make this green hydrogen production as the feasible one. Okay, and so these are some of the details, state-wise details of this implementation of this green hydrogen mission. Yes, so this is the timeline framed by the milestone framed by at present on this green hydrogen sector by India. And this is the projected green hydrogen demand by 2030 and the financial year 2050. And you can watch that a range of demands in various sectors. Okay, so of that, the main is on the refinery side. Yes, the next one is developing and enabling ecosystem. So that's a very important one. If you want to promote the green hydrogen technology and production, a supporting a good ecosystem must be developed from the government side. Then only we will be able to mature this technology in a good manner. So for that, we need to develop our green hydrogen hubs in various states in India to promote these all incentives and policies, so that localized green hydrogen production can be encouraged. Okay. Yeah. So these are the challenges. Okay. So we discussed the type of hydrogens and the necessity of hydrogen, the and the opportunities of hydrogen, green hydrogen policies or like that. But these are some of the challenges. Lot much of challenges are there. Since at present the technology is in a infant stage. See, this technology is in an infant stage. We need lot much of developments to mature this technology. So cost reduction is extremely important. So per kg hydrogen production is very high cost. It is almost $2 per kg at present. We need to reduce the cost. We need to reduce the cost of production per kg hydrogen production. It is extremely important. Okay, and a lot much of initiatives and support is necessary there from the government side. And knowledge supported decision making and large scale system studies. Then suitable areas need to be identified. Large scale manpower and training efforts are needed, and codes, standards, regulations. See, this is the new thing. This is a new technology and it's the emerging technology. Once we are moving to the commercializing this green hydrogen production, we need to frame codes, standards, and regulations. So the codes, regulation, and standards are different for different countries. So different suitable to India, we need to frame different codes and standards for the green hydrogen generation, and that has to be taken, or the frame that has to be framed from the government side. And not much of initiatives are there already taken for this framing the standards and regulations. Okay. Yes. Then challenges in scaling green hydrogen. Okay. So first of all, once the technology is in the infant stage, the first thing is pilot projects. The green hydrogen things are at present there lot centers are there, production centers are there at present in India, but all production is under pilot stage. That pilot production of green hydrogen has to be scaled up to the higher quantity. Okay, so for that, not much of challenges are there for that. And the detailed challenges are there, incentivizing demand, because not much of companies are there, firms are there which are ready to invest in this green hydrogen production, but this is a infant technology, so incentives must be given to the users or the customers for the production of this technology. See, already not much of incentives are there for laying solar panels in our homes. Like that, we need to, the government has to give not much of incentives to the different companies, those who are ready to produce green hydrogen in different in India. Okay, so that is the challenge one. And the challenge two is limited enabling infrastructure. See, a big infrastructure is necessary for this green hydrogen production, and this infrastructure is limited nowadays, and it is only able to produce the green hydrogen in the pilot manner, and we have to increase the infrastructure very high, and need to be, the production target of green hydrogen will need around 125 gigawatt of additional renewable energy. See, if we want to produce green hydrogen, we need renewable energy, and almost we need 125 gigawatt of renewable energy capacity to produce green hydrogen, and it is, the ambition is of 500 gigawatt of renewable energy capacity by 2030, and this is the energy target is India expecting. Okay, 2030, 500 gigawatt non-fossil capacity, 50% of installed capacity from non-fossil fuels. This is the target by 2030, and 2047 India has to become energy independence, and by 2070 India is going to make it as net zero. So this is the National Green Hydrogen Mission. So these are all the activities from the government side what are making to promote the green hydrogen production. Okay. So these are the activities under green hydrogen missions. So lot much of proposals are invited from MNRE and other funding agencies like DST. MNRE has the major role of inviting proposals in R&D and pilot projects. So these are some of the areas: electrolyzer manufacturing, green hydrogen production, pilot projects in transport, proposal. And I think almost the Indian government has already been allotted from some 1,000 crores of rupees is allocated for National Green Hydrogen Mission, and that all fund is utilized for this different initiatives under Green Hydrogen Mission. And this is the competitiveness. India has a good feature for, and the global cost advantage for green hydrogen from India is approximate $1. We are expecting to make the cost of the per kg hydrogen to less than $1 in 2030. So coming to Kerala, so this is the net zero vision of Kerala. The government of Kerala has already framed some policy to make the state as net zero 1. So these are the initiatives from the government of Kerala side. As Indian National Green Hydrogen Mission, Kerala has its own Kerala Green Hydrogen Policy, and it is under draft. Not much of initiatives are there, and budget allocations are there from the state side to promote this green hydrogen production. And this is some of the pilot projects already. Kochi water metro is there, as you all know. Water metro is there, and of that, some of the boards And one boat is running as the hydrogen-powered ferry vessel. So it is India's first fully indigenous hydrogen fuel cell. It is in our Kochi, and under process is hydrogen-powered feeder contained vessel. And this is the initiatives under CL, Cochin International Airport Limited, and agreement is already is signed to produce the green hydrogen by using the renewable energy available in the Kochi International Airport. Already, as you all know, that a big generation is solar energy power generation is there. Using that solar power, they are going to produce green hydrogen in the CL itself, and that producing green hydrogen is going to use for various purpose, and first for transportation. And the agreement is already signed. I think the BPCL is already in the role. They are 100 NMQ per hour GH2 output from 500 kilowatt electrolyzer system. So this is the sizing of that their green hydrogen generation from CL. And there is a small
commitment to a sustainable future aims for net zero emissions by 2070. At the forefront of this endeavor is the adoption of green hydrogen as a maritime fuel.
भारत को हाइड्रोजन फ्यूल आधारित ट्रांसपोर्ट की तरफ ले जाने का जो हमारा मिशन है, उसको कोच्चि शिपयार्ड और सशक्त कर रहा है.
Crafted at CSL stands India's pioneering creation, the first indigenous green hydrogen fuel catamaran vessel. This vessel champions urban mobility, setting a remarkable standard for sustainable waterway travel. Developed in collaboration with Indian Register of Shipping, CSIR India, and KPIT. The vessel is poised for deployment in the historic city of Varanasi shortly. The ferry promises to support clean transportation through zero greenhouse gas emissions, quieter movements, and lower lifetime operating costs. The vessel was flagged off by the Honorable Prime Minister of India on 28 February 2024. Designed with urban mobility in mind, similar vessels will soon grace the waterways of other regions. Let's unite our efforts and set sail towards a greener future, inspired by the promise of clean energy and sustainable innovation.
So these are the pilot projects in fuel cell and high trucks. The government is Kerala government is planning to run trucks, hydrogen fuel cell vehicle trucks between cities, and it is under planning. And Kerala as a GH2 hub. Okay, the Kerala is actually playing a very big role in this green hydrogen sector. Okay. So these are some of the challenges. Shortage of time is there. We need not to discuss this. Yes, the main one, the chicken and egg dilemma, is the final one. The hydrogen economy faces a unique challenge because dilemma arises from the independence between hydrogen production and consumption. So which one comes first? Hydrogen production or consumption? For this instance, consider the decision to purchase a hydrogen-powered vehicle. Such a decision is less likely if there are no accessible. Once the hydrogen-powered vehicles are there, and if we are not accessible to hydrogen fueling stations, that hydrogen-powered vehicle cannot be used. So there is a thing which has to be made first. Whether we need to first initiate the infrastructure for the hydrogen production, or we need to initiate the developing the hydrogen vehicles. So which has to be done first. So definitely this is the chicken egg dilemma, and so two things has to be done parallelly. Then only we will be able to meet all this demand. Yes, I would like to finally share some our achievements in this green hydrogen. And the previous the February month of this 24, we attended a hydrogen hackathon jointly organized by Government of India and the Government of Netherlands, and we became the first in this hackathon. And as a reward of this hackathon, we were able to participate in the World Hydrogen Summit held at Netherlands in 2024. and it was a great experience for us, and we were able to experience different research and developments in these hydrogen sectors. Lot much of researchers and lot much of companies which are doing the green hydrogen productions were there. A lot much of exhibitions, a lot much of sessions, technical sessions were there. It was a very nice exposure to us. And we have submitted that what are the outcomes, and we have given some recommendations to the university. So that has to be, so see, the teacher community has a big role on this promoting this green hydrogen things, and lot much of initiatives has to be taken from the university side, and the recommendations are given to the KTU. And also we have recommended we have submitted a report to the government, to the Additional Chief Secretary Jyotilal sir, and the outcome of our visit to Netherlands, and we have given some recommendations on what are all the state initiatives has to be taken to promote the green hydrogen generation in Kerala. And as a result of this outcome of our achievement, and already Kerala has a draft of Hydrogen Valley. They have already submitted a proposal to Government of India for the allocation of fund to create government valleys, green hydrogen valley in Kerala. And Kochi was one of the hydrogen area to consider in the hydrogen valley. And after our achievement, Trivandrum is also considered into this hydrogen valley. And our idea has to be implemented in this hydrogen valley, and we hope that will be considered by the government. And this is the very recent, we visited the NTPC Energy Technology Research Alliances to visit the green hydrogen production there. We have visited the different areas in the NTPC in Netra. This is the water purification area and the electrolyzer which are used for the hydrogen production. And the photo shows the total setup of the green hydrogen generation. We visited the plant, and we came to know that how the green hydrogen is produced from the water, sewage treated water. Okay, so these are all the experiences. And as I already told, this is not just the session, this is not just the knowledge. This is our combined journey towards making decarbonizing this planet. So let us make a pledge, or let us make effort to decarbonize this planet together. Thank you. Thank you very much for the patience hearing. Yes, and
Sir, thank you so much for your wonderful session. Thank you so much. It is an interesting session. So thank you so much. Okay, sir.
Okay, thank you.
Angela ma'am.
Yes, sir.
So, Sindhu sir.
Moving on,
We can start.
I would like to introduce our next esteemed resource person, Dr. Senthil Kumar. Thank you, sir, for taking the time to join us today. We are honored to have you with us for this session. Dr. Senthil Kumar is a professor in Department of Electrical and Electronics Engineering at NIT Tiruchirappalli. He holds a PhD from the same prestigious institution. He has had an impressive professional journey serving as an associate dean at NIT and also the tech nodal officer. He guided more than 93 PG students and guided more than 10 PhD candidates. His contributions to the field include assisting in our nine successful R&D projects and publishing more than 42 research papers in reputed journals and 28 conference proceedings. We are fortunate to have someone of this caliber here to share his expertise. Let's extend a warm welcome to Dr. Senthil Kumar. Thank you, sir, for being with us. Over to you, sir.
Yes, thank you, ma'am. Thank you for your introduction. Very good evening to all of you. Can I share my screen?
Okay, sir.
Okay. Screen is visible?
It is visible, sir. So full screen, sir. Please put it in the full screen. Okay, sir. Okay.
Yeah, now screen is visible, no?
It is visible, sir.
Okay, fine. So, very good evening to all of you. Today, my talk is overview of environmental stewardship and social responsibility in renewable energy systems. So, first of all, you need to understand what is environmental stewardship and social responsibility related to the renewable energy systems. And government can play a role in promoting the renewable energy through policies and incentives. So first of all, we need to understand the need for renewable energy, like climate change and its impacts, the depletion of fossil fuels, energy security and concerns. So then the definition of environmental stewardship is a responsible use and protection of the natural environment. So yeah, again we can say that it is a set of values that guide how individuals, communities, and cultures interest with the environment. Environmental stewardship can include restoration, scientific research, and community action. So social responsibility, the definition, one can understand that ethical framework that guides organizations to contribute societal well-being. That means a consideration for enterprises in the development process. So again, we need to understand with respect to the government policy. So governments can promote renewable energy through policies and incentives such as carbon price, a positive impact on the investor enthusiasm, and subsidies beneficial for renewable energy investment in supply chain. Then green certificate trading improves the investment level of electricity sellers. Then generation based incentives encourages wind power development. Accelerated depreciation benefits encourages wind power development. So bioenergy promotion promotes the use of biofuels and biomass based power generation. So the renewable energy can contribute to sustainable development by improving access to energy for rural people, enhancing agriculture output, driving economic growth, improving energy security, and mitigating climate change. So here we need to understand that the importance in a renewable energy is aligning green technologies with environmental and social goals. So coming to the environmental stewardship in renewable energy. So I said already it is a reduction of carbon footprint. So for example, the solar, wind, hydro, geothermal energy system produce the minimal greenhouse gases. Then conservation of biodiversity, careful setting of renewable energy projects. Then resource efficiency, use of sustainable materials and recycling in production. So then societal responsibility in renewable energy, one can understand that consulting legal communities in project development, job creation, promoting employment in the renewable energy sectors, energy equity, ensuring affordable and accessible energy for all. So here we need to understand stewardship strategies. Particularly, I just want to discuss about the wind energy system. Wind energy as a clean renewable energy source offers numerous environmental and economical benefits. However, it is essential to implement effective stewardship strategies to minimize its potential negative impacts and maximize its long-term sustainability. So here are some key strategies we can follow, like environmental stewardship, careful site selection. So identify sites with optimal wind resources while minimizing the impact on wildlife ecosystem and cultural heritage. Conduct through environmental impact assessments to evaluate potential risks and development mitigation resources, then wildlife conservation also. So that is implement and measures to reduce the bird and bat mortality, and such as using radar systems to detect and deter birds, and timing conservation construction and maintenance activities during periods of low bird and bat activity. Collaborate with the wildlife experts to design bird and bat friendly turbines and operational practices. So these are the some aspects like we need to be followed. So similarly, like a landscape uh, preservation. So minimize the visual impact by careful sitting and design, and integrate wind farms into the surrounding landscape, restore disturbed land into its original state, are more beneficial uses such as restoration or agricultural. So the another important factors while considering with wind energy conversion system is noise mitigation. So the noise mitigation, something like we can say that employ noise reduction technologies such as acoustic barriers and optimize blade design to minimize the noise pollution. So here one of the case study I'm going to discuss related to the blade only, and establish buffer zones between wind farms and residential areas to reduce the noise impact. Then social responsibility, again I told you community engagement. And then land power relations. Land power relations means establish a fair, uh, equitable lease agreements with the landowners, then provide a timely payment and address any concerns or issue promptly. Indigenous rights. So respects indigenous rights and cultural heritage, and obtain necessary permits and approval from relevant authorities. Consult with indigenous communities to minimize impacts on their traditional lands and practices. So coming to the challenges in achieving the goals. So the environmental concerns with respect to habitat disruption from large scale projects, then recycling and disposal of renewable energy materials with respect to the social challenges, then opposition from communities like NIMBY, not in my backyard, balancing affordability with the technological and advancements. So we can make plenty of case studies with respect to this area. So for example, offshore wind farms minimizing the marine impact. Social responsibility is example is solar cooperatives in underprivileged communities. So these are the some case studies that we can make it with respect to the sustainable operations, particularly for community engagement, involve local communities in the planning and the development process to address the concerns and building support, provide transparent information about the project and its benefits and potential impacts, offer opportunities for local employment and economic development. So these are the uh, uh, topics are related to the examples. And coming to the environmental stewardship, so particularly we must know how life cycle assessment for all the renewable energy system, innovation in recycling technologies for components, social responsibility, something like um, and partnership with the local governments and NGOs training and reduction programs for clean energy jobs. So the key matrix for evaluation, the important key matrix we can consider with respect to this topic is carbon emission reduction, biodiversity impacts assessment, then social metrics is number of jobs created, then energy affordability and access statistics. So these are the things we need to be considered while discussing with respect to this topic. And so some aspects here I just want to discuss with respect to stewardship strategies for large composite wind turbine blades. So I just want to give some introduction related to the stewardship strategies. Already I have given. So in so here I am going to discuss is predicted around 42 million tons of composite waste from wind turbine blades will need to be recycled annually worldwide by 2050. So actually this information I have taken from one of the article titled State of the Art Review Product Stewardship Strategies for Large Composite Wind Turbines, so authored by Daniel Martinez et al. This proposes actually potential environmental crisis that must be timely mitigated. Therefore, here this study proposes an integrated multi-level product stewardship to address the environmental impacts of wind turbine blade waste. So this product stewardship integrates circular economy, clear protection, eco-design, industry 4 technologies. So here I just want to discuss the overview only with respect to the topic like a stewardship strategies. So to tailor the proposed product stewardship, a systematic literature review only very much essential, and the industrial report is also very much essential. Then the large variety of technologies were identified under 7 different potential pathways that can be combined to address the environmental impact of wind turbines. Moreover, a technology roadmap and a product strategy plan composed of 5 milestones to be achieved by 2050 were presented in envisioning the maturation and adaptation of the solutions. So let us see here the diagrams that represents distribution of the total offshore wind power per country in 2021. You just see that. So here the first diagram, the A diagram that shows that the different countries, the total distribution of onshore wind power capacity, like Canada, UK, France, Brazil, Spain, India, and total energy capacity is also is there. So here you can see that where it is China, where it is US, and Germany, then India. So then second one, it represents with distribution of total offshore wind power per country in 2021. Actually, this one represents with like China, how it will be, Germany, UK, Netherlands, Denmark, like that it is there. So, and the third one that it is represents new installations of global onshore and offshore wind power per year adapter. So this characteristics, I mean the bar chart we have taken from this article, and the corresponding it is represent 2016 how much, 2017, but every year it is going to be increases both onshore and offshore also it is going to be increases. And here you can see that the fourth one, the distribution of the global composites marked by application in terms of volume in 2016 adapted from this one. So here you can see that a marine, defense and aviation, logistics, construction and building, electrical and electronic, and pipe and tank, consumer goods, wind energy, how it will be. So this will give you the overall information about the system, that is the wind energy system, both in the onshore and offshore. So this is the thing. And coming to this characteristics. So this characteristics that explains where the stewardship strategies for large composite wind turbine blades. So this is with respect to the cumulative installed capacity of wind power in Australia and Australia capacity generation plan in 2050, how it will be in terms of gigawatts and in terms of terawatts hour. That it is with respect to different sources of power it is given. So here we can say that how it will be the coal, the other bioenergy, then wind, gas, so and the combinations, hydro, solar, everything it is there. And when you are referring United States, so the United States, the regulatory scenario in the US is completely different compared with the EU. In the US, landfilling of large composite materials is the most common route for disposals due to the lack of regulations and the cost of efficiency and the alternative. In 2008, the US Energy Department released the US Energy Plan. It is a report called as 20% of nation's electricity demand by 2030. According to the Wilburn et al., to reach the goal of the proposed wind energy plan in the US require between the 2.3 billion and 2.7 million tons of composite material. So these are some information related to the wind energy conversion system. Similarly for Australia, so in Australia, the wind power is currently the cheapest source of large social renewable energy. As a result, the Australian installed wind energy capacity has been steadily growing since 2016, moving from 41812 to 9041 megawatts in 2021. And so there was a dramatic changes in the wind energy conversion system. The Australian government's approaches is to unlock the investment and accelerate the technology deployment by removing barriers such as taxes and providing incentives and finance for finance for firms to deploy the wind energy technologies. So, nonetheless, despite the Australian government efforts to encourage investment in wind power, there are no current plans for the management uh, of waste generated from wind turbines. So unfortunately, Australia does not have the large-scale facilities for recycling carbon fiber and fiberglass composites suitable. And the government considers the carbon taxes are regressive with significant costs. So currently in Australia, there are about 101 wind farms from which 15% are over 15 years old. So hence, if we estimate the composite waste which will be generated when dimensioning of wind turbines will start, then accordingly to present installed capacity, so it can be increases. This we need to understand. So that is why everywhere there was a project proposal, something like waste management. And coming to the search strategy. The search strategy, we need to understand. So the search strategy that indicates with the various process. So a record identified in various sources, total records. So records after duplicates are removed. So then records scanned, records included, and full text article. These are the some related to the literatures. So when you are to the with respect to the um, purpose and objectives, taking into the consideration for the need for the deployment of high-level management strategies to initiate global collaboration to ultimately avoid the potential environmental crisis triggered by the waste of wind turbine blades. So this study proposes an integrated product stewardship approach for wind turbine blades. So this study is aimed to set foundations for a global environmental collaboration to binding together in all the different um, actors. So here the stakeholders, economic and technological factors to address the environmental challenges with respect to the wind turbine blades. Yes, the current study sought to achieve the following main objectives with respect to this area. So present an umbrella product stewardship to integrate circular economy, CE, cleaner protection, then eco design and industry 4 technologies I told you earlier, and present the different potential product stewardship strategies and pathways that can be taken to address the environmental impact of wind turbine blades. Then identify the TRL, technological level. So of potential technologies and present year technology roadmap of the pathways that can be taken to address the environmental impact of the wind turbine. So present a major plan and strategies to direct the maturization and adaptation of solutions to address the environmental impact of the wind turbine blades. So when you are considering about the materials, uh, there we need to consider many factors. So this is a qualitative exploratory research study that is focused on proposing a multi-level product stewardship. So to address the environmental impact of the wind turbine blades, so for this purpose, we actually it is required to employ a constructive research approach which is aims to produce innovative solutions to practical problems in a heuristic manner. The solutions are commonly proposed using managerial problem solving techniques through the construction models, diagrams, plans, organizations, uh, uh, organizations like that. Then the recommended solutions require the searchers to immerse themselves in the contextual literature to allow an in-depth interpretation and the synthesis of the problem. So yeah, coming to in this regard, we need to have a very good data collection. So the data, for that only I told you, like data collection, we can make it with the different sources like Google, Science Direct, like that. So then the search criteria. The search criteria is another important information while considering with the materials and methods. Actually the search criteria, it is also based on the literatures. So from the literatures, it has to be find it out like how much I mean the with respect to the material, how much the technologies which is available, and and the industry and the government reports how much it is so far it is existing, that we need to understand. Similarly, for data extraction and analysis, based on this only we can do it. So coming to the products stewardship strategies, uh, one can consider that at the highest level, the product stewardship acts as a engineering management umbrella. So that integrates the remaining hierarchical level, the uh, social level is a CE, then representing the economic factor that makes the possible, the viable closed loop production and the consumption of natural resources. At the third level are the design and manufacturing factors. So for example, eco design, cleaner production that allows the design and the production of the green wind turbine blades. So this diagram very clearly it gives an idea about integrated multi-level product. So multi-product stewardship framework for wind turbine blade, that is integrated product stewardship, circular economy, cleaner production eco design, industry 4 standard. Then least favorable option is prevention, reduction, refurbish, repurpose, recycling, recovery, disposal, like that. So in this, we need to consider like health monitoring, digital twins, self-healing materials, architectural use, structural use, uh, incineration, then cement cleaning, then landfill, sustainable materials, like that. Then mechanical properties also we need to consider, pyrolysis, then fluidized bed, microwave bed, then uh, so solvolysis, then solvolysis, then economical. These are the things that we need to be considered with respect to the industrial standard. So coming to the conceptual design, conceptual digital twin reference model for the wind turbines adapter. So with respect to this article, and here, so with respect to this article, I mean, here you can see that with respect to the wind turbine, what are the areas it has been covered. So a large variety of potential technological solutions identified to drive the wind energy industry towards more environmentally sustainable practice. Some of these solutions are from engineering side, the development of novel materials and implementation, recycling technologies, to name a few. According to the waste management hierarchy, sustainable development and resource efficiency can be achieved using a top-down strategy. The main goal of the waste hierarchy is to facilitate the selection of the options most likely to deliver the best overall environmental outcome. So therefore, the 5 R's waste hierarchy serves as template to present different potential opportunities to overcome the potential environmental crisis that can result from incoming waste generated by the disposal of the wind turbine blades. So in this regard, we need to consider different pathways and technologies that can be taken and combined within the proposed integrated multi-level product stewardship wind turbine blades. So in this regard, we need to consider the prevention strategies. So according to the prevention strategies consist of measures to taken before substance material or product has become waste in order to prevent waste generation. In the case of wind turbine blades, the prevention strategies should focus on the life extension of blades as well as the optimization of their design and manufacturing process. Better design strategies can help to reduce the non-renewable resources. So with the renewable resources, the optimization of manufacturing process and allow to produce the wind turbine blades using less resources and avoiding uh, production waste. The life extension of the wind turbine blades prevent the disposal of the blades combined composite material for several years, opening a window opportunity for industry to move into environmental friendly alternative. However, to unleash the full potential of waste prevention strategies and achieve high level of economy and sustainability to improve, to link all the aspects of life cycle of the wind turbines. So this may require converging the physical and cyberspace through an appropriate flow and use of both data of both worlds. So for this purpose, Industry 4 technologies and such as structural health monitoring, digital twin, and self-healing materials are to be integrated. So an integrated digital twin for wind turbine blades life cycles we needed to we measured in this regard. Many literatures are available in this process. So here you can see that how the models are adapted. So with respect to the physical layer, digital layer, cyber layer, then smart manufacturing, smart design, like that it is shown clearly. And coming to the working principle advantages and limitations with respect to the different uh, damage detection methods used in wind turbines. So here we need to see that the structural design, that is damage detection method, acoustic emission and the corresponding working principle, use of piezoelectric sensors to detect the stress waves created by the blades, uh, material, stress releasing process during the failure. The advantage is a mild range. It can detect microstructural material challenges such as cracking, delamination, and fatigue. Can assess the damage severity. It can determine the location of the damage point. So rapid and efficient, non-invasive, and then real-time monitoring. The limitations is demands a large number of sensors, requires a data acquisition system with a high sampling frequencies. Signal processing is complicated, cannot provide information about the material internal structural stress, high cost. So similarly, when you are considering with the thermal imaging, infrared sensors or cameras are used to detect temperature differences caused by the subsurfaces defects in the material to identify material irregularities or damage. So the advantages are global range. It can measure the surface stress distribution, size of cracks. It can identify stress concentrations, invisible subsurface damage, root delamination, and trailing edge cracks, thermal damage. It can be used to evaluate bonding quality and entrapped air produces a full field measurements in the image form. So here one can understand that the limitations are for wind turbines blades applications requires external stimulus tools. Then limited application for online monitoring can be affected by the environmental conditions. So some methods, the damage reduction methods are used as ultrasonic methods, used as the ultrasound waves to identify the material defects that are oriented perpendicular to the direction sound provocation. So the advantages we can claim that mild range, it detects the material damage, uh, small as a few millimeter delamination, cracks and interlaminar weakness. It can identify location and the severity of the damage. It is efficient and reliable. Can provide scanned movie or snapshots of the structural damage. So the limitations are only can detect defects that are oriental perpendicular to the direction of the source wave provocation, cannot detect a single fiber rupture, and requires a surface cannot long acquisition time. Signal processing is complicated. So most of the places the model based only they are using. It detects the changes in the material physical properties using model parameters such as frequencies, model shape, and model damping. The advantages we can claim that global and social range, it can accurately predict the location of the damage, is easy to implement, requires the data from LP material regions to be compared with the damage areas, and it is not easy to extract local information caused by the small damage, uh, unable to monitor uh, early damages. And coming to the working principle, so the advantages with respect to the fiber optics, of course, the fiber optics, it is very good only, and uses optical fibers to sense the material strain. The advantages is mid-range, short length. Optical fiber can be embedded into the composite material during the fabrication. Real-time reduction of early damage, transverse crack evaluation and impact damage. Then on-site calibration is not required, can simultaneously read the large number of sensors on a very few fibers, leading to reduced cabling requirements and easier installation, can monitor strain and temperature simultaneously. Then automatic eye sensitivity can be used for lifetime protection, long-term stability under operation hostile environments, competitive cost. Then the limitations that can be affected by the environmental conditions, fragile, the data acquisition unit expensive and bulky, requires a prior knowledge about the high strain areas, requires a large amounts of sensors. So then many methods like this, it is there like laser Doppler vibrometer, then electrical resistance based damage detection. So this is also conventionally people are using. So uses the conductive property of the carbon fibers to measure electrical resistance changes in the material. So it can detect the fatigue damage, matrix cracking, delamination, and fiber breakage. It can determine the location and the size of the damaged areas. So the limitation is the local range, and it can only be used with the carbon fiber reinforced composites. The traditional strain gauges also people are use electrical sensors that are sensitive to differing electrical properties. Global range can detect microscopic material changes, does not require external power. So then nowadays it requires a large amount of sensors prone to failure, then measure only point strain, then requires a prior knowledge about high strain areas, then expensive, large, I mean the smart memory uses the changing the magnetic global range, but it is expensive, labor intensive. And coming to then very recently, people have started to use with X radiography, then eddy current, then computer vision. So computer vision uses the binocular vision detection method to obtain the sequences of two to the three-dimensional images to obtain the information of the target of the object. But it covers the global range suitable for online monitoring, detection of the surface damage, high detection accuracy and efficiency, low cost. Then one can understand that the limitation is only detect the visible external damages, high requirements on imaging devices, and data processing capabilities. So actually, in fact, we got some images. Our students are working related to the image processing, and finally they are finding the where it will be the exact damage with respect to the wind turbines. Actually, the same concepts the people are using with a variety of areas. So, for example, as an electrical engineer, insulation, I mean the insulator failure, for that also people are applying the image processing. So many areas they are using this concepts. And coming to this one, the schematic of the different thermosetting rinses that can potentially be used in a combination with the different fiber types to produce new polymer matrix composite materials for the wind turbine blades. So here, the advantages we can climb with respect to the different material. You can see that like a glass, carbon, then flax, jute. So the different materials they are using, and here we need to understand that how they are using those things. So with respect to the factors like reduce strategies. So in view of the end life of the future wind turbines, the use of the sustainable materials and new manufacturing process that can help to cut from its roots the environmental impact of the next generation of the wind turbine. So this can be achieved with the introduction of Industry 4. Every time I am quoting the same standard, Industry 4's technologies to simulate the behavior. The behavior of the wind material with respect to the wind turbines. So that is a complex materials and used in use of additive manufacturing process to produce lighter, stronger, and more energy efficient blade geometrics with less materials. So less materials. The so here we need to understand the new materials and manufacturing methods. So so here this diagram will give you an overview only, but this diagram what are the materials, I mean the composite materials which are used in the manufacturing of the wind turbines. So, according to the literature, Seculario et al. So, as published one article in Science Direct, so he quoted that the original equipment manufacturers are mainly drawn to novel materials that are capable of reducing the cost and manufacturing cycle times. As a result, little work exists in industry alternative materials to counteract the environmental issues of the current fiber reinforced materials. So, however, in the last two decades, numerous studies have been conducted and are underway to develop the new materials for blades to improve their performance and efficiency, to reduce the volume of the material and improve the recyclability. That is very, very important factor. So some of these materials are reversible and self-healing, thermoset resins, uh, thermoplastic resins, then biodegradable resins, then natural fibers, and hybrid fibers. So this and all we need to understand. So hybrid fiber composites. So here in this regard, we needed to understand this structure. You can see that. So this is represents with the schematic of the different thermoplastic resins that can potentially be used with the combinations with the different fiber types. So different fiber types, how they are using. So I said that different factors. So that different factors like self-healing, thermostat resin, thermoplastic resins, biodegradable, natural fibers. So all these factors we need to be considered. So while developing with respect to the wind turbine blades. And but each is having the own standards. So that also we need to be considered. So some of the properties, the mechanical properties. So the mechanical properties, already I have dictated some of the properties, self-healing, thermostat, thermoplastic, biodegradable, like that. So at the end, we need to recycle. So while recycling, we need to take taken care. So many, I mean, the funding agencies also they are calling the projects in this area. So how we are going to recycle, so such as the wind turbine blades, solar PV panels, that and that. So in this regard, we need to consider the standards which is given by the government, and some of the factors we need to be considered in this regard. And some of the mechanical properties of natural and synthetic fibers. So you just see that these are the some standards with respect to the various literatures it is given, like Fitzgerald et al., then Khalil et al., Azim et al., then Nayak et al., so Ozin et al. So the various mechanical properties they are considering, and the corresponding tensile strength, how it will be the Young's modulus, how it will be, elongate, how it will be, the density, specific stiffness, specific strength. So all those things we need to be considered while discussing with, I mean, while designing with wind turbine blades. So here, one more important, all biodegradable polymers have the performance and processing issues. So for wind turbine blades, some of issues include low mechanical properties and fiber affinity. So several researchers efforts are and hence underway to create blends of these polymers such as PHA, PLA, PBS to enhance their mechanical properties and achieve controlled biodegradability. So this we need to be keeping in our mind. So the different thermoplastics. So that we need to see here different thermoplastics. So that is the configurations of the thermoplastic resins with different types of available fibers. So that we can understand from here, like natural fibers, natural hybrid, and natural synthetic, carbon or glass composite. So like that, many it is there that we need to be considered while designing the wind turbine blades. So here, I just want to show you some of the topology optimization simulation of plant lead in wind turbine structure. So that looks to be like this. So here the first diagram, it shows with the topology optimization simulation with respect to the different uh, wind turbines. So here it is showing that if we can understand how it will be the structure. And the second diagram that represents with the 3D of printing plant leaf mimetic architecture prototype. And that it is represented here. And the C, it is that is architecture prototypes. So uh, that represents originally printed flat blade without heat treatment. It is there in the left, and bent twist coupling after the heat treatment, that it is there in the right. So then C and D, E represents these three diagrams. Just you see that conceptual uh, tidal turbine blade section during infusion process and final finishing blade. So all the diagrams, it is there with respect to the corresponding literatures, it is shown here. And so these are the few factors we need to be considering while designing the wind turbine blades. So the promising manufacturing technologies such as additive manufacturing and potential change and offer the opportunity to overcome some of the challenges of the wind turbine fabrication methods such as cost, labor incentives, and time consumption, adaptive manufacturing, fabricates, parts by joining the materials layer by layer. So like that we need to be considered. The main advantages of adaptive manufacturing technologies is the ability to fabricate a complex shapes that are, and so when you are referring the wind turbine, we have both horizontal axis also and a vertical axis also. The shape of the blade is also completely different. So in this regard, we need to consider the complex shapes that are possible with the traditional manufacturing method. Therefore, need to design for manufacturing becomes obsolete, thus eliminating the traditional design constraints. So, due to the manufacturing flexibility, the adaptive manufacturing, just-in-time production becomes the natural manufacturing environment. So, with the use of adaptive manufacturing, it is also possible to create the blade design that challenge the traditional blade design of the wind turbine. So, for example, uh, Momini et al. He has used a mimicry approach to design a different kind of wind turbine blades based on the plant leaves. So several studies had previously demonstrated that blades designed based on the branched network leaves have smaller stress intensity, better static strength and stiffness, lower internal strain energy, and higher fatigue. So many factors, I told you, like something like a modular wind turbine. The modular wind turbine blades help to overcome the challenges in the fabricating and transporting the large wind turbines. So can be fabricated with thermoplastics using the adaptive manufacturing, and process can be scaled for large blades. So based on this concept, several researchers have proposed the use of adaptive manufacturing for on-site production of the wind turbine. So I just want to show you one more diagram. This is represents with the mechanical properties and natural synthetic fibers. So here we can understand that the first diagram represents the 3D printed wind turbine mold by Oak Ridge National Laboratory. It is all the pictures from that laboratory only. First one is represents with a low pressure section. The second one represents with 5 out of 8 low pressure side model sections. Uh, Additively manufactured blade mount and produced blade section. So finally, a final high pressure mold images, so that it is represented with B, C, D, and E by kind permission with this one. So actually, I have taken from this article only. Then the post ATAL article. The size comparison of the master print wind turbine system, the largest 3D printer in the world, that it is represented in the diagram E. Then the last one represents with the demonstration of the master print. 3D printer capabilities by kind permission of Ingersoll and Thomas. So, and the mechanical properties of the natural and synthetic fibers. So, we can say that with respect to the many properties. So, I just want to tell you one more information with respect to the manufacturing. Uh, manufacturing is based on the Mounds Ingersoll machine tool company in partnership with Arnold Development, the first wide high adaptive manufacturing system with the built-in computer numerical, that is a CNC control milling capabilities. So the master print of wind turbine system can 3D print objects within a working volume of 6 meter multiplied 6 cross 4 cross 2 meter, and it can be equipped with a 3 or 5 axis milling head. So this compositive 3D system can be used to manufacture complex design blades and molds made of thermoplastic carbon fiber composite materials, producing less material waste. So here we need to understand the architectural use of wind turbine blades. So the different architecture it is shown here with respect to the wind turbine system. So the first one, A and B, represents the Ricardo playground designed by the upper use. So here you can find how it is represented. The main properties we need to consider while recycling, I mean the refurbish and manufacture and repurpose strategies, everything we need to adapt. Then sometimes we may get with the industry incentives also, and we need to follow with recycling pathways also. So here the C and D represents the public seating in Williams Flynn. So before and after repainting, how it will be. Then the E represents with bus stop shelters at Almar Ports station designed by superior use by kind permission. So the last one, the bike shed in port of Aalborg, Denmark by kind permission of Henrik Eilers. So you just to see that how they are using. And coming to the relevant applications for researched recycled composite materials together with a conceptual closed loop materials flow of the transfer from structural aeronautical component to powder filled thermoplastic component adapted from. So here this graph it is given clearly with respect to the fiber reinforcement potential in industry against the fiber enforcement type. So here with respect to the various properties like structural, aeronautic, so it has been considered and the important factor is also the cost. So actually when you are looking several efforts have been made by the industries and the research to develop the different recovery methodologies for polymer matrix fiber reinforced composites such as mechanical separation like milling, grinding, and thermo-economical properties. So, and some of the literatures also it is given like mechanical recycling, thermal recycling process, then like pyrolysis process, then fluidized bed process, microwave pyrolysis process, chemical recycling process, then high temperature solvolysis, then low temperature solvolysis. So low temperature solvolysis is a dissolution only. That is a low temperature solution solvolysis, also called as a dissolution, allows for the recovery of both the polymer matrix and the full strength. So from the thermoplastic and thermosetting fiber reinforced composites. So actually, dissolution is similar process to high temperature solvolysis. However, it can only use as the solvents and it is performed at temperature less than 200 degrees centigrade or at a room temperature. So using this process, it is possible to recover thermosetting composite materials with a near 100% recyclability. So moreover, the process can extract with the mechanical properties similar to those already existing, including the epoxy matrix, which can be repolymerized to fabricate the composite material. So, and we need to see that here the summary and advantages and disadvantages of the recycling methods. So I said that different recycling methods which is available. The mechanical recycling that indicates with industrial scale, low operational cost, medium investment cost, low energy consumption, no use of hazardous material. The disadvantages are degradation of fiber, mechanical properties, short fibers are recovered. So pyrolysis is industrial scale only. Again, the medium operational cost, a low investment cost, a high retention of fiber mechanical properties, no use of mechanical solvents to tolerate to material contamination, energy recovery. By products can be used for production fuels and oils. So the disadvantages is high energy consumption, release of hazardous of gases. So fibers contaminated with characteristics and changes in chemical structure. The process difficult to control. So similarly, like fluidized bed, micropyrolysis, solvolysis, supercritical water, high voltage fragmentation. So that also one of the recycling method. So in that that is industrial scale potential, high retention of fiber tensile strength. Then short fibers are recovered. The disadvantage, high decrease of materials of I mean the high decrease of modules of glass fiber. So the material flow and the technological specifications of the fiber reinforced polymer composite materials. So you just see that the structures, how it will be from the waste, like a processing capacity, retained strength, tensile strength. So this I have taken from the one of the particular article. So we need to follow like a recovery and disposable challenges. That also the very important. And so this one is one of the Miljo's curve products made of recycled wind turbine. So the recycled wind turbines, you just see that the first diagram represents with reflective noise barriers they are using. The B and C is absorbent noise barriers to reduce the traffic noise. So for that they are using. And the last one, cross section of the reflective noise barrier by kind formation of Miljo's cram. So this is used very recently. So still the people are working towards the material for the blade design. This diagram represents the technology readiness level for industry and the commercialization purpose. So this will give the roadmap plan for product stewardship solutions for the wind turbine blade waste. So and TRL extracted from various articles. So the industrial reports that it is reported here, and it is represented with respect to the TRL level 1, 2, 3, 4, 5. That it is represented very clearly, and with respect to the milestone achieved, with respect to the various factors like prevention, reduce, refurbish, repurpose, recycling, recovery, and disposal it is given, and corresponding the milestones achieved also, like how it will be something like provision of disposal, landfill. So like various factors how we can consider that also. Here it is a reporter, and the various strategies for the technology roadmap for the product of stewardship solutions for the wind turbine blades are the milestone A is I mean the repurpose and refurbish. The milestone B, like that, the same diagram, it is reflected in the tabular form. One is interested, you can go through, and that the corresponding duration, the strategies involved, then requirements, the corresponding outcomes is also there. So I can say that the milestone F. So with respect to the milestone F, the outcome, you can see that 100% of fiber recovery from the wind turbine blades with 100% retention properties and length. Then establishment of the global circular economy system for high performance reversible wind turbine blades. Establishment of a global circular economy system for high performance wind turbine blades made of natural and natural property, natural and hybrid properties. And I just want to conclude the session. So here I have given some overview of stewardship, strategies for large composite wind turbine blades. So in the response of the potential environmental crisis that can be resulted from the incoming waste generated by the disposal of the wind turbine blades. So this approach brings together the different actors, stakeholders, economic and technological factors to set the foundations for a high-level management strategy for global environmental collaboration to address this issue. For this purpose, the different states of the technologies, materials, designs, and recycling solutions that can help to mitigate this environmental problems were explored, including the various industry efforts that have been taken, made to address the problem. So having this in mind, a technology roadmap and strategy plan were proposed with different potential circular economy pathways currently available, taking into consideration the TRL of the discussed technologies. So nonetheless, further studies and simulations with the different scenarios are required to quantify the most feasible pathways for the numerous stakeholders involved. Moreover, to achieve the proposed endeavor, a strong geometry, the governmental support is necessary to create appropriate industry standards. So, yeah, industry standards, accelerate deployment of technologies with industrial potential, and finally, industry must acquire practical experience. So, by adapting stewardship technologies, wind energy can continue to play a significant role in sustainable future, providing clean, renewable energy while preserving the environment and benefiting local communities. So these are the just overview, and further if you want to have, you can refer this article. So this article will provide you the most of the information. So this article is published from School of Engineering and Built Environment. So Griffith University, Australia, and so here they are given the complete information, the state of the art review product stewardship technologies for large composite wind turbine blades. Thank you.
Thank you, sir. So, questions, if any questions from the participants?
Actually, it is completely related to the materials and recycling process. So I have given, according to the topic, I have given the overview, the complete overview. And further details, you can refer my PPT. This most of the information I have taken from the articles only.
Okay, sir. Okay.
And industrial reports.
Okay, sir. So then, so there is no questions I am thinking so from the participant side. So, okay, sir, then we can now wind up the session. So, thank you, sir, for your insightful session. We are immensely grateful for the time you dedicated to be with us today. Your insightful session was both enlightening and inspiring, and we truly appreciate the change to learn from your expertise and experience. So, thank you so much, sir. Thank you.
Thank you.
Thank you, sir.
Thank you,
Thank
Dr.
you. Thank you, sir. Thank you. So, dear participants, kindly fill the Google form. And today's sessions came to end. So tomorrow, day 3 session, it will be starts at 6 p.m. So thank you all.
So can I leave, Praveen?
Okay, sir.
Thank you, everyone.
Okay, thank you very much, sir.